Good day, viewers all over the world. You are welcome to Toydel online class. Today, we want to look at example on the inverse of a matrix. In this case, we have 2 by 2 matrix. That is, matrix A is given as 1, 2, 3, minus 2. So we want to find the inverse. So the inverse of A is denoted as A inverse. And by formula, as we have discussed, it simply means the adjoint of A all over the determinant of A. And as we have rightly said, that we can only find the determinant of non-singular matrix. That is, the matrix that the determinant is not equal to 0. If you have a matrix and determinant is 0, we cannot find the determinant. So in this case now, the first thing that we are going to find is the determinant of A. Let's see, the determinant of A. The determinant of A, of course, we know how to find the determinant of A. We multiply the leading diagonal, that's 1 times minus 2, minus the ordinary diagonal, 3 times 2. This is what we do. So 1 times minus 2 is minus 2. Then minus 3 times 2 is 6. So the determinant of A is given as minus 8. So in this case now, A is non-singular. Non-singular in the sense that A the determinant of A is not equal to 0. So we can go ahead and find the inverse of A. And if you want to find the inverse of A, also, we said that there are three things that we are going to do. We first find the minus, we find the cofactor, and when we now transpose the cofactor, it is called the adjoint. So we go ahead and find the minus of A. How do we find the minus of A? The minus of A by formula will be equal to, now look at, if you want to find the first minor of A, we pretend as if we cover the first row and first column. What we have, the leftover is minus 2. So the first value here will be minus 2. If you want to find the first row and second column, we pretend as if we cover first row and second column. We are going to have 3. That's what we do. We come to this one where we have second row and first column. We pretend as if we cover these 2. We are going to have 2. Then the last value will be second row, second column. We are going to have 1. So this is the minus. This is the minus of A. Then after the minus of A, we go ahead and find the cofactors of A. How do we find the cofactors of A? Cofactor simply means minus with appropriate sign. In this case now, the appropriate sign that we are going to have, this is 2 by 2. The appropriate sign will be plus, minus, minus, plus. That will be the appropriate sign. So in the first column now, in the first row, first column, this is minus 2, this is 2 plus times minus, that will still be minus. We have minus 2. The first row, second column, this is 3, this is minus. Minus times plus, that's minus. We are going to have minus 3 here. Then we go ahead and to the second row, first column, plus, minus. Plus times minus, that's minus. We have minus 2 here. Then the last one is plus, that will be 1. So this will represent the cofactors of A. Then the adjoint of A, the adjoint, this is abbreviation for adjoint. The adjoint of A simply means when you transpose the cofactor. Adjoint simply means when you transpose the cofactor. That is first row to first column. We are going to have minus 2, minus 3, minus 2, 1. So this will represent the adjoint of A. So we now know the determinant of A. The determinant of A as 8. And we have gotten the value of the adjoint of A as this. So the inverse of A, which we are required to find, will now be the inverse of A is same thing as the adjoint of A all over determinant of A. So in this case now, the adjoint of A is given as minus 2, minus 2, minus 3, 1. Divided by the determinant of A, we got the value to be minus 8. Finally, we can rewrite this and say, no, this is the final answer. But we can go ahead and rewrite this as, say that the inverse of A is same thing as minus 1 over 8. I may decide to bring minus 1 over 8 up to have minus 2, minus 2, minus 3, 1. So this is what we are required to find. So if you have to find the inverse of A, the first thing that is required is for you to find the determinant of A. The determinant of A will determine if that matrix have inverse or not. If the matrix is non-singular, that is, whenever you find the determinant that is not equal to 0, it shows that that matrix is inversible. But once you find the determinant and the determinant is 0, then that matrix has no determinant. Thank you.